cybersecurity in 2026 is less about building higher walls and more about preparing for two new realities, quantum era risk and a world where identity is the new perimeter. The first trend is agility towards quantum cryptography, because the threat isn't that quantum computers are coming tomorrow. The threat is harvest now and decrypt later. Adversaries are collecting encrypted traffic today, betting that they can decrypt it later when quantum capabilities mature. So the secure path in 2026 is to treat encryption like an inventory problem first. That means identifying where your most sensitive data lives, both at rest and in transit, mapping the cryptography your business depends on, certs, VPNs, signing, and key management, and prioritizing the systems with the longest data shelf life, where exposure a year from now still matters. The key shift here is agility. Organizations aren't just updating their encryption protocols, they're building the ability to redefine cryptography without ripping apart critical systems. That's how you migrate safely in phases without breaking performance or trust. Trend 2 is identity first, zero trust. This year you'll witness that the traditional network perimeter is dead. Apps are everywhere, users are everywhere, and data moves across environments constantly. So identity becomes the only perimeter that matters. That means access is no longer a one-time login event. It's a continuous, context-aware trust. Trust is granted based on signals like who the user is, what they're trying to do, device health and security posture, location and risk factors, and whether behavior matches what normal looks like. In practice, the goal isn't to slow people down, it's to reduce the blast radius. If identity is verified continuously and access is right-sized dynamically, a stolen credential becomes a contained incident, not an enterprise-wide crisis. And once you're confident in who can access what, the next bottleneck is where all that compute actually lives, and how it's being powered and cooled. In 2026, data center strategy is being rewritten by AI, and the limiting factor isn't ambition, it's heat and power. Trend 1 is liquid cooling going mainstream, specifically direct-to-chip. AI-ready environments are pushing rack densities beyond what traditional air cooling can handle reliably. Liquid cooling is moving from a specialized solution to a standard implementation, because it's the practical answer to GPU-heavy data clusters that dissipate massive amounts of heat continuously at scale. What this means in practice is a major shift in facilities and IT infrastructure. Design decisions now include cooling loops, redundancy planning, and serviceability, because the infrastructure has to support sustained performance, not just peak benchmarks. Trend 2 is power scarcity and the rise of on-site microgrids. For many operators, power availability has replaced land as the primary constraint for expansion. The challenge isn't finding space, it's securing enough reliable electricity for AI workloads that don't tolerate interruption. We're seeing data centers evolve into energy strategists, integrating on-site generation, storage, and microgrids to stabilize supply, protect uptime, and reduce dependency on a stressed grid. In other words, the modern data center isn't just a compute hub, it's delivering its own power grid to supply this new infrastructure. And when power and cooling become first-order constraints, this changes the economics of where workloads should run. That brings us to the cloud. Cloud in 2026 isn't a destination, it's a portfolio decision. The question is no longer cloud or on-prem, it's which workload belongs where and why. Trend 1 is the great repatriation and the move toward a smarter hybrid. After years of cloud-first momentum, many organizations are taking a hard look at steady-state workloads and asking, are we renting what we should own? The driver here is cost control. When workloads are predictable and long-running, cloud rental can become expensive. So enterprises are moving specific systems back to on-prem or into co-location to regain pricing and performance leverage. The key here is a smart hybrid, not reversing cloud adoption, but optimizing placement, so each workload lands where it's most efficient, secure, and controllable. Trend 2 is the rise of neoclouds, providers built specifically for high-performance GPU compute rather than broad, general-purpose services. This is a direct response to the AI compute surge. Organizations need access to GPUs at scale with strong performance and clearer economics, especially for training, fine-tuning, and high-throughput inference. So in 2026, cloud strategy expands. It's not just hyperscalers versus on-prem, it's an ecosystem that includes specialized compute platforms purpose-built for AI. And once workloads are distributed across on-prem, co-location, hyperscalers, and specialized GPU clouds, the connective tissue becomes the network. Let's talk about what's changing there.
Here's the reality. Networks have grown too complex for the old school change and praise strategy. Today, the team that wins is the one that simulates first and deploys with confidence. This trend is called the network digital twin. Think of it as a living virtual replica of your network. This is where your topology, policies, routing behaviors, configs, and even traffic patterns can be simulated. Instead of the old school pushing a change in production and hoping that the blast radius is small, engineers can model the impact of the change in advance. Whether it's a new segmentation rule, a routing update, a firewall policy tweak, or an SD-WAN adjustment, you're simulating it, measuring the outcome before you even touch the real environment. So what's changing this? It's easy. Your networks become more distributed. You have remote users, branch offices, an HQ, perhaps 3 different cloud instances, and many SaaS applications. You have to provide that same user experience despite where that user is, which means you have to ensure that your security policy is tighter. And these misconfigurations can be very costly. The other thing to note too is downtime. It's less tolerated, especially for real-time applications. So what does this mean in practice? It means that the digital network twin can make changes predictable. Teams can simulate, validate, deploy, and roll back with clarity, reducing risk for any environment. Imagine the impact that this can have on your organization, especially if you're a regulated industry, or tasked with a network integration for a merger and acquisition, or if you struggle with global refresh cycles. Think of the impact, again, that this can have. The second trend that we have is Wi-Fi 7. It's becoming the de facto standard for wireless network refreshes. And the headline isn't just speed. The real-time business value is lower latency, improved reliability, which is critical for modern workspaces supporting real-time applications, such as collaboration, AI, or immersive training. So if you're planning a refresh, the question isn't whether you want faster Wi-Fi. It's whether your network needs to be instantaneous, consistent, and resilient no matter the work that happens. And once this network becomes faster and more reliable, the next pressure point is obvious. It's your applications, especially if they are AI enabled. Hey, let's talk about what's actually changing there. In 2026, AI isn't defined by faster content generation. It's defined by AI doing real work, securely, repeatedly, and at enterprise scale. First, AI is entering production. Generative AI produces the content, agentic AI executes the outcome, and AI agent is how the design shows up in practice. Think of an AI agent as a digital operator, software that can understand an objective, plan the steps, interact with enterprise systems, handle exceptions, and complete the task end-to-end with a full audit trail. In practice, agents are becoming the new middleware layer, connecting tickets, documentation, CRM platforms, finance approval, and knowledge systems into automated workflows. Adoption is accelerating across customer support triage, IT operations, procurement, employee onboarding, and sales enablement platforms. This isn't a magic bot. Enterprise-grade AI demands enterprise discipline, clear permissions and guardrails, tightly controlled tool access, human-in-the-loop oversight for high-risk actions, and deep observability. Because when an agent takes an action, you need to know what changed, when it changed, and why. Second, AI is rewriting the data loss prevention playbook. This risk isn't theoretical. Employees can unintentionally paste sensitive information into public AI tools or upload proprietary documents to get answers faster, creating exposure across intellectual property, customer data, contracts, and regulated information. Because of that, data loss prevention is evolving. Traditional data loss prevention focuses on blocking file movement. Modern data loss prevention focuses on governing AI interactions. That means controlling what data can be shared with AI systems, enforcing policy on prompts and uploads, logging and governing AI usage, and guiding users towards approved secure assistance. The goal isn't to slow teams down. It's to enable AI adoption with guardrails, so employees can move fast, get value, and innovate without leaking the organization's most valuable data. Third, intelligent edge, bringing AI closer to where the data is created. As AI becomes operational, we're starting to see the shift. Instead of sending data back to a centralized location, Organizations are processing the data at the edge. Factories, hospitals, retail locations, branch offices, and vehicles. So decisions happen in milliseconds and not seconds. The benefit is immediate and measured. Lower latency, reduced bandwidth costs, greater resiliency when connectivity is limited, and real-time automation. Here's a look as to what this could look like in the real world. Think of quality inspections on a production line, anomaly detections at a substation, or fraud signals at a point-of-sale system. And once AI becomes operational and edge compute expands, there's a major downstream shift. How organizations buy technology. That shift starts with procurement. Procurement isn't just buying tools. It's about continuously managing risk and providing outcomes. First, real-time vendor risk monitoring. The old model relies on annual questionnaires and point-in-time assessments, but supplier risks don't change annually. It changes constantly. Breaches happen, financial conditions shift, layoffs, leadership turnover, regulatory pressure, and geopolitical events can impact the vendor overnight. As a result, organizations are moving toward a live risk posture. AI is increasingly used to track signals such as security incidents, operational disruptions, financial stress, compliance, red flags, and supply chain instability. Vendor risk becomes an always-on dashboard, not just an annual spreadsheet. That's how organizations avoid surprises and keep critical services running. Second, we're seeing a lot more outcome-driven based technology adoption. Instead of purchasing components such as licensing, features, or modules, teams are increasingly buying measurable outcomes, faster time to resolution, accelerated onboarding, improved conversions, reducing infrastructure cost per workload, higher uptime, and fewer security incidents. The shift does three things. It accelerates time to value, it reduces implementation risks, and it ties technology spend directly to business strategy. If an outcome isn't defined, the purchase is just hope with a budget. The broader shift is readiness, then execution. Success isn't driven by chasing the next capability. It's driven by being ready to execute. That readiness is built by securing the enterprise for a post-quantum identity-first future, modernizing data centers for power and cooling constraints, and reshaping cloud strategies for AI-era economics. From there, execution becomes a differentiator. Simulated networks, governed AI, and technology investments measured by outcomes and real-time risks.